This is a Panasonic circuit board used in a non-inverter air conditioner. This is the indoor PCB, and as you know, there's no PCB in the outdoor unit for non-inverters. So today we'll discuss the common causes behind tripping issues in this PCB. Sometimes the compressor repeatedly trips, or the unit runs but doesn't produce any cooling. We'll explain the possible reasons for these issues. Now, one challenge with this PCB is that it doesn't have error codes, which Panasonic often omits in these models. So, when a problem arises, you won't have error codes to guide you, making it harder to understand the issue. Now, I'll explain a few methods to help you check where the fault might be in the unit. When there's a tripping issue, it's not always just a problem with the PCB. The outdoor unit might also have its own faults that contribute to the issue. One possibility is that the compressor's capacitor has become weak. If it's faulty, you'll experience tripping issues. The compressor will start but then shut down. In this case, replacing the capacitor might solve the problem. Another possibility is that the compressor's windings are weak or damaged. When the windings weaken, the compressor can overheat because it can't handle the load properly, leading to tripping. If the compressor is getting hot, it might be due to this issue. If the condenser is very dirty, it can also cause problems. A dirty condenser reduces cooling efficiency, which may cause the unit to trip. In this case, you should clean the condenser thoroughly and check if the problem persists. If the problem continues, inspect the fan motor to see if it's running slowly or if its capacitor is weak. A slow fan can lead to overheating and tripping issues. Once you've checked all these things, if the compressor is still tripping suddenly, it could be an indoor unit issue. To isolate the problem, you can cut off the indoor unit's power supply and directly supply power to the compressor and fan motor in the outdoor unit. Run them directly to see if they operate correctly. If they work fine with direct power, then the issue may be with the indoor unit. Another thing to keep in mind is that if the refrigerant in the unit is low, this can also cause issues. Additionally, if the capillary tube gets clogged, it can lead to problems as well. These are some of the outdoor-related issues that could be causing the problem. However, we have the indoor unit, which can also have faults that cause issues. One unique aspect of Panasonic units is that they don't have error codes. Even if a sensor, motor, or any other component fails, the unit may just start tripping without indicating a specific error code. This makes it challenging to identify whether the problem is in the sensor, motor, room sensor, or elsewhere. Here, you can see that I've started the unit and the green light has turned on. The motor has also started running. I've set up two motors here. This motor is compatible with the unit, and since it's compatible, the unit's power supply and other outputs are functioning correctly without causing any tripping. You can see that the indicator light is on, showing that the output is active. Now, I'll connect the other motor and I'll demonstrate how it causes tripping. This will help you understand how using an incompatible or faulty motor can lead to tripping issues. Now you can see that the motor was running, but the green light turned off, and the output has also stopped. There's no output, and the whole unit has shut down. The possible reason for this is an issue with the feedback signal. The motor is running, but it's not sending proper feedback to the PCB, or there could be a fault within the PCB itself. There's also a chance the motor has a problem. If the motor starts, then stops, and the output shuts off as well, meaning the compressor trips, this indicates that the fan motor might be faulty. Its feedback is not functioning correctly, and the PCB is not receiving a proper feedback signal, causing repeated tripping. Sometimes it works, sometimes it trips. To fix this, you can try directly replacing the motor. This might resolve the problem. Now, watch as I only press the temperature button and the unit turns on. Right now, it's off, but as soon as I press the temperature button, it powers on. This shows that the PCB is functioning. However, because it's not receiving the correct feedback signal, it's causing issues. The PCB is detecting that there's no feedback from the motor, so it's triggering these problems. This lack of feedback is why the unit keeps shutting down or tripping. When there's a motor issue, it's usually easy to detect because the motor will stop running, the unit won't operate, and there will be no output. Without output, the compressor won't start, so you can identify a motor fault easily in this way. However, if the sensors are faulty, the motor might still run. As long as the feedback is correct, the motor is functioning properly and it's not jammed. In this case, the issue is likely with a sensor, and often it's the pipe coil sensor that goes bad. Although the room sensor can also fail, it's less common. The pipe coil sensor failure is more likely. Let me share the correct values for these sensors, so if a problem arises, you can test by replacing them with sensors of the proper resistance value. When you use the correct resistance value, the unit should start functioning properly again. Now we'll check the resistance value, but remember, the room temperature was 31 degrees earlier. Currently, we've placed the display sensor in water, and it's showing a temperature of 25.5 degrees. Next, we'll place the pipe coil sensor in the water as well to ensure it reads the same temperature, as both sensors should have the same resistance at the same temperature. After placing it in the water, we'll need to wait a bit for the sensor to adjust to the water temperature and provide an accurate reading. This way, we can confirm that the sensors are functioning correctly by comparing their resistance values at the same temperature. Now, let's test the sensor and check its values. The pipe coil sensor is currently reading 19.67 kiloohms at 25 degrees. If a sensor is faulty, it may show fluctuating values, sometimes one value, sometimes another. This indicates it needs to be replaced. In this case, you can install a sensor rated at 20 kiloohms for it to work correctly. Next, let's talk about the room temperature sensor. We'll also place it in water. After waiting for some time, we measure its resistance value, which shows between 14 and 15 kiloohms at 25 degrees. So if you replace it with a 15 kiloohm sensor, it should function correctly, and your unit should work properly. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.